Welcome to example 4 of homogeneous, and this one has initial condition. So the question is xy square times dy dx is equal to y cube minus x cube. So I'll rewrite here again. Uh, the text is not very clear, so I'll write it down again just in case. So xy squared times dy dx equal to y cube minus x cube. And the initial condition is that y of 1 equal to 2. So geometrically, this means the graph has to go through this point 1 comma 2. The x is 1 when y is 2. So the graph has to go through this initial point 1 comma 2. So that's a geometric picture. Okay, so first solve for dy dx. So I dividing both sides by xy square. So let's go ahead and do that. Y cube minus x cube divided by xy square. Let's distribute the denominator. So I get y cube over xy square minus x cube over xy square. So let's simplify. So I can cancel out y square with y cube and I left with y. I cancel with x cube and I left with x square. So all I have now is y over x minus x square over y square. But of course, x square over y square, I can write as x over y square. And remember, x over y is actually 1 over y over x. So x over y is actually 1 over y over x. Because when you flip it, you get the same thing. It's like any fraction, 2 over 3 is 1 over 3 over 2, correct? So it's that because we want to express everything in terms of y over x. So let's actually write it down finally. Dy dx equal to y over x minus x over y. Sorry, let me rewrite in that way. 1 over y over x square. So everything in terms of y over x. So let's do that same substitution as we always do for the homogeneous. Please make sure you watch the previous videos for the other example of homogeneous. So I have v equal to y over x, cross multiply, y equal to vx. Remember, v here is a function of x because y is a function of x. So at the end of the day, y over x is a function of x. So let's take the derivative of both sides with respect to x. So dy dx equal to product rule, dv dx times x plus v. The derivative of x with respect to x is 1. So let's substitute. So in place of dy dx, of course, I'm going to substitute this. And in place of y over x, I'll substitute v. So that goes in place of y over x. So let's see what I have now. Dv dx times x plus v equal to v minus 1 over v square. I can cancel v from both sides. So let's see what I end up with. I have dv dx times x equal to negative 1 over v square. Let me write this way, distribute the square. And 1 square is 1. Okay. So we can use the same type of trick, or you can in here you can just simply think I can multiply both sides by v square. So if you multiply both sides by v square, all I have is -1 on the right, and we're going to flip over this on the other side. So let's do that. So in this side I have v square dv. On the other side I have negative dx over x. So the negative is coming from here. And when I flip x over dx, I get dx over x. Of course, this I can rewrite as -1 over x dx. So let's take the integral of both sides. So here I get v cube over 3, or 1/3 v cube, equal to negative the integral of 1 over x is ln x plus c. So let's multiply both sides by 3. I mean, we need to simplify as much as possible. Let me add a blank page here. Okay. So let's actually multiply both sides by 3 to simplify, to get rid of this 1/3. So let's multiply by 3. And remember, 3c is actually c, because c absorbs any constant. So I end up with v cube is equal to -3 ln x plus c. Again, 3c is just c. An arbitrary constant absorb that factor 3. Okay, let's at this point, let's substitute back. Remember, v is equal to y over x, so don't forget that. So let's substitute this back in place of v. So let's do that. So I get y over x cube equal to -3 ln x plus c. So here I can, so this is just y cube over x cube. So why not, let's multiply both sides by x cube. So at the end of the day, we're simplifying, this as much as possible. So technically you are done, but what we are doing, we are actually simplifying, and it is always advisable to simplify. So this cancel out, because in real life, you want to simplify a complicated expression as much as possible, right? And this will give you the most simple version of the solution, right? So let's multiply out here. So I end up with -3 x cube ln x plus cx cube. And why not I move this to this side? Um, Here actually you can take the cube root of both sides to see an explicit solution, but let's not do that. So let's just write in this way. So y cube plus 3x cube ln x equal to cx cube. So that is the general solution, general um, implicit solution. Let's use the initial condition. So my initial condition is y of 1 equal to 2. So let's do that. Y of 1 equal to 2. So I have to substitute x equal to 1 and y equal to 2. Let's do that. So in place of y, I substitute 2. In place of x, I substitute 1. And remember, ln of 1 is 0. So this ln of 1 is actually 0. So that will make whole thing 0. because 0 times anything is 0, right? Okay, very good. So we like the number 0, right? As long as it is not our paycheck at the end of the week, we don't want $0, right? Otherwise 0 is a favorite number. Okay, so what I have here is 8 equal to C. Very good. So now I know C is 8, so that goes in place of C, and that is our final specific solution. Remember, when you have initial condition and you solve for C, that is called specific solution. So the general specific solution, the specific implicit solution, the specific solution is y cube plus 3x cube ln x equal to 8x cube. And that will be our final solution. That's the final, the specific implicit solution. Let's use GeoGebra and see, can we find the C visually by graph. So let's do that. So I'm going to go to the GeoGebra. That's our previous example, so I'm just going to delete that. Okay, so let's start fresh. So we start with putting C and then enter. So that will be our slider for the C. I want to change the setting because negative 5 to 5 is too small. So let's just make it negative 10 to 10. Negative 10 to 10. I don't know what happened. Let's try again. C, enter, setting, slider. Let's make it negative 10. 10. Okay, very good. Now let's enter our general solution in terms of C. So I'm going to enter the general solution, this one. Our general solution is this one. So I'm going to enter this general solution. So let's do that. Y cube plus 3x cube times ln of x, absolute value of x, equal to C times x cube. Wow, look at that weird picture. Look at it. I like it. So maybe I can zoom in. Wow, this is good. It's like a cubic equation, so it makes sense. Okay, let's enter our initial condition. Remember, the initial condition is y of 1 equal to 2. So the graph has to go through this point 1 comma 2. So let's call that point A. It's going to be 1 comma 2. That's my that's the initial condition here. So this is not the specific solution because this does not go through this point A. At this point, your C is 1. You can see it from the upper left. My C is 1, right? So let's move this slider so that the graph goes through this point A. I mean, we know algebraically we already found that C is supposed to be 8, right? But let's check it. So as I increase the C, you can see the graph is getting close to A. Very close, actually. Right there, 7.5, but it's not exactly on the point. You can see if I zoom in, it's not quite there, right? There are some gap. So let's increase it. Oh, that's too much, too much. Actually, at C equal to 8, The graph is actually goes through that point A. If you zoom out, you're going to see the overall, the big picture of our solution there, right? So that's the graph of our specific solution that we're interested in. Amazing, amazing. Do not forget that you can always do it, and always believe in yourself. Thank you. Bye bye.